Welcome to Data Science Conference Europe 2020 Open Day. This is the Artificial Intelligence track, and my name is Anita Jovic. I will be your host for the first slot. So expect great content and lots of fun. You're going to hear the opening keynote from Yong Shi from Chinese University and Academy of Science. Yong Shi is a professor at University of Nebraska, and he will give us his unique view of what is the difference between theory and practice in data science and how may we overcome it. So feel free to ask any questions, and our keynote speaker will be happy to answer them after the presentation. Also, hop into the official DSC Discord server, where you can find the invite on our homepage and join the fastest growing data and AI community. So, Yong Shi, the floor is yours. Thank you.
Hi, good morning for European time. My talk today is called Data Science, Theory, Analysis, and Applications. My name is Yong Shi from the Key Lab of Big Data Mining and Knowledge Management from Chinese Academy of Sciences. Okay, today's lecture will cover 5 points. The first one is called optimization-based data mining. So from this part, so I will start with the introduction. In year 2020, this is a year, right? It has been passed for 20 years ago. So 20 years ago, I published a paper in the US encyclopedia. It's called data mining. In my point of view, the data mining can be viewed as a process, a selection, transformation, mining, and interpretation for 4 stages. So again, my idea is very clear. So data mining is not just the using of algorithm, but it is the process of the decision making. So from my idea point of view, if given the data set, you are not going to use all of them, but you will choose some data set or subset you are going to use. Because data mining is task oriented. So given the data set, you have to transform the data from different scales into the same scales is called normalization. In the big data situations, you may have a data as non-structured data. You have to transfer those non-structured data, something like photos and voice into the format which we can use. That's called transformation. The third stage is called data mining. So only for this stage, we can use the algorithms to analyze the information, either by use algorithms developed by somebody else or by yourself. So this only part is for computer science. The last part is called interpretation. So from here, again, you are going to think about how the knowledge can be performed. For example, if the results of data mining is regarding the stock market, if you do not buy stock, then the information for you is not knowledge. But for the people who are playing stock is knowledge. But the knowledge even for them is today, but maybe it change for tomorrow. So knowledge is changing with situation and also with individual. So this is my point. And for the methodology point of view, data mining can be viewed by clustering, association, classification, sequential patterns, prediction, and similar time sequence. So the key part of data mining over here is, for example, like a clustering analysis. So normally the people, will classify the data if they don't know the index or whatever the labels. So I can put the people, for example, by the ages. If you are talking about age below 30s or above 30s, so below 30s will be first group, the above 30s will be second group. Then we are going to divide them into 2 parts. So for the associations, we can think about some ideas like what Walmart is, for example. So in the grocery business, so we can find that. So some people who buy the diapers also buy beers. So they are potentially become the customers who are the single fathers. That's identification. So most of the situations of data mining is related with classification. So which means that if we know who are the good, who are the bad, then we are going to use a mathematical model to record them to see if they are good, they are bad. Then this will come to have two kinds of mistakes. The mistake one could be, you treat the bad person into the good person, or mistake two or type two could be you treat the good people as a bad people. So anyway, so this is the methodology of data mining. Then we can use regression analysis to look at the predictions and so on. Okay, so that's just functions. So let's look at the history of the data analysis. So our human being has been used data analysis for about 300 years. So in 1783, a very famous, statistician, his name is called Richard Price, has published a paper is by using the collection of the taxpayer information in British counties, then to predict what's the national data of the country. So this is very, very important. Now let's look at what he has done. This is his original paper. So you can see we have rows, something is called, the records. We have columns is called variables. So, even now, if we look at the data analysis, we call this table is called multi-dimensional table, or I just choose to say this Richard Price table. So we have now we have hundreds of thousands of rows, hundreds of thousands of columns to use. So this is different now. So this is our situation for today. So, and for some of you, you may know that Richard Price is a good friend of Thomas Bayes. So Thomas Bayes is a person who gave us Bayes law. So basically, Thomas Bayes never published a paper. It was his friend Richard Price published what he said. Finally, we recognize as Bayesian theory. So this has been used for many, many years. Now still are important items for our data analysis. So let's look at what's going on with the information we are talking about. Here I'm talking about what's optimization-based data mining. That's a major topic of my research. So on the left, we can see from optimization situations, we have objective function. So this can be mapped to the classification function. So from these classification functions, we can see the following three items. The first one is contrasts. So contrasts related with the classification criteria. And we can transfer the information of the solution into the data mining field is called classifier. And for the rules to find the solutions, we can use the complex structures, which is symbol one, to relate what we call is the preference of the decision makers. So if you can see from left, we have optimization have been successfully transferred into the data mining as ideas. So again, what I want to demonstrate is the optimization structures can be used for the data analysis. Let me just give you one example to see how those things can be used. For example, we have ideas over here. So like this is two persons. So one is AI, another one is A2. So AI is one person, A2 is another person. For example, we say A1 is John, A2 is Tom. So we are going to classify if they are good or not, depends on their credit scoring. So the credit score can be classified as by salary and age. We can see, first one person, John's salary is 6 and his age is 8. 6 maybe has been, we call 30,000, US dollars, and age is 20. So why we use 6 to represent 30, we use 8 to represent 20 because of scales. So we have normalized scales, okay? So same thing, about the Tom. So Tom is 8, 12, okay? So to relate with sales salary and age. By the data analysis, we use the boundary of 10, then we can classify them into the solution for, first coefficient is 0.4, second one is 0.6. So you use 0.4 multiple 6, 0.6 multiple 8, you can get 7.2 for John and 10.4 for Tom. So this is called the linear score, so the score we have. Then from this chart, we can see that, okay? So if we have a boundary 10, and for John, his score is 7.2, for Tom is 10.4. Definitely, this boundary give us a clear idea, John's credit score is bad, Tom's credit score is good. So this is called the separation. But however, this is just one example. In the real life, we do not have a situation like this. We call this perfect separations. So, but in our real life, we have a situation like this. So, for example, so we can see that. So we have a left, circle is bad, for example. A right circle is good. Okay. So then we have a boundary over here is cutting both situations here, and you can see that for this point is go beyond the boundary. So we call this is overlap. So we want to minimize this overlap. And for this beta over here, that's pointed to the adjusted boundary. So we call this is a distance. We want to maximize distance. So again, if we minimize alpha, maximize beta, we will put this circle to this left, and we will put this circle to the right. So that's how we can separate them, okay? So basically, what is data mining? We can use the idea to show you data mining is data separation. So we will separate data from something like, good in the bad, bad in the good, okay? To have, accuracy as high as possible, okay? So that's the situation. So this is the idea of data mining. So through this idea, so we can say lots of things to do it. For example, if we have three groups, we say left part of the group is bad, the central part is ugly, then this is good. So we have three groups, right? So we have to have two cuts, the cut one, a cut two. So to try to handle what's going on with group one and group two, there's overlapping. What's going on with group two and group three, there's overlapping. Of course, if we say this hyperplane has been existing, okay? So we can prove from theoretical point of view, whenever you need the uncut, then you can separate n plus one, groups, or vice versa. If you have n groups to separate, if you have hyperplane, you can use n minus one cuts. But the more cuts, the more difficult the model will be. So that's a trade-off. So this is the basic ideas for the optimization data mining. Okay, so here is about the examples. So you can see that if we have 14 items over here, so to classify, and by use age, by use income, by use student, by use credit, reading. So this is about 4 variables. So then we have labels over here. Yes means has computer, no means no computer. But you have training results over here. Either can create a bad case or good case. For example, we call type 1. So suppose this guy has low computer, but you say he has a computer. So that means this guy could be bad guy, and you call this guy good guy. So this is called type 1 error. This is error. And here, this guy has a computer, but our results say no computer. So this is type 2 error. You treat good as a bad. So this kind of a mistake, like in statistics, always happen is called type 1, type 2 error. We try to minimize those errors. There's no model to give you 100% accuracy. So that's a data separation, okay? So from this data separation, we develop so many algorithms from our research group. Okay, we have almost more than 40 or 70 algorithms. Now, I'm going to turn my attention to the second item is called intelligent knowledge. So first, I talk about what is optimization-based data mining. Second, I will see what is intelligent knowledge. So this is our creative ideas. In many situations, people only think about how to find the hidden patterns from data mining, but they never think about how the people is going to use the results of data mining. In year 2006, so I did a consulting business with one of IPO companies in US market. So through data analysis, we found that there are about 245 cases which is rules can potentially become a knowledge, because this is just like the goods or email systems people use. So the CEO told us they have hundreds of people join their business every morning, but in the afternoon, half of them are gone. That means their services are not very good. So from hundreds, thousands of patterns, they don't know how to handle it. So through data mining, we use C 4.5. That's the software for decision tree to analyze it. So the results still have 245. It's a lot. For me, it's a lot. But when I present this idea to the marketing manager, she said, "Oh, Dr. Shi, you already find the results, because I know you are 245. So the rule 1, the rule 8, rule 12, rule 13 is something I need, but I don't know the rest of 241. What's going on?" So I told my student, I said, "You see, in the data mining field, we never talk about how to bring the decision maker's mind into the process to select the knowledge. If we use a computer program to classify the patterns of her thought, I mean the marketing manager thought, then to screen the 245 to find out 5 or 6 different words, including 4 what she wants, then we will become big success. So in this way, so we are talking about this is called the intelligent knowledge. So your idea is very clear. So data mining can be regarded as the first order of knowledge mining. It's a result of rough knowledge. To find the knowledge for users as a decision support, the second order of data mining, or we call the knowledge mining, is needed. So that's how we have a second stage. Whenever the data mining results come out, we have to combine with what decision maker wants to further identify exactly what one they use. Okay, that's called the intelligent knowledge. So of course, if you look at this, you will go back to see what's the basic definition of the knowledge, right? You can define the data, define the information, rough knowledge. Those are very common. So, and we can see that. So from this idea, so the first transformation with data mining we can view is we transfer the data from the data to the from data to the knowledge. We call this rough knowledge. That's the result of data mining. If we go back to say more, we have to look at in the area of human knowledge. So we can treat human knowledge as several categories. The first one is specific knowledge. Second one is empirical knowledge. The third one is common sense. That's also knowledge. And we have instinctive knowledge. And we have situational knowledge. So we treat those knowledge together. We will give a definition of the intelligent knowledge. So what does that mean? So knowledge is called intelligent knowledge if it is generated from the rough knowledge is from data mining, and all those specific knowledge, empirical knowledge, common sense, situational knowledge, by the situation we have, we call this is the second order analytical process. So you combine machine knowledge with human knowledge, basically, okay? So that's called the second order. So second order become intelligent knowledge. So this is called the mapping is from the knowledge from the machine, we call the rough knowledge. And the human knowledge could be one of the subset of those 5 different categories. So we can have a second mapping. So this is called intelligent knowledge. I want to just point to you, this is a brand new ideas, in the field. Okay, so from this field, we can see that we can study the data, from data to rough knowledge, to intelligent knowledge, and to actionable knowledge. So normally our data mining is on the first stage, is transfer the data into the rough knowledge. In our research, we combine human knowledge together. So we are talking about intelligent knowledge. If we put the problem with itself, description, and also environment together, we can look at the strategy for the business. So finally, we can go to the actionable knowledge or the wisdom. So basically, we can do from data all the way to the wisdom or to the actionable knowledge. So I told my students we can do research for this for 40 years. Even now, we are still high on T1 or T2. We have to talk about T3 and T4. So this is a future trend of the data analysis. This is what I share with you. It's very key ideas. Okay. So this is my 2 points. Now I'm going to the third point. Is called big data analytics and cases to share with you. So I don't know, some of you may say this cartoon or not. So you see, this is the idea of big data. This person who is a customer trying to get a service from this service person. So after collecting his information, the service person runs the big data systems. So finally, so he said one sentence was below. So the first one, he said that your recent Amazon purchase and tweet score and location history. So that means big data has sources come from the company corporation, company's database or cooperative database. Second one is data from online, okay, from online. The third one is location history, the data from government. So data mining for the big data. So the data source come from, the first one is the company, the second one is first one is company, the second one is from the open sources, the third one is from government. So that's a point one. Then he said the second point, we make a very precise analysis for you. We found that your welcome rate over here is 23.5. This is very interesting. This the dollar didn't say 23, didn't say 24. That means 23.5. That means so data mining will give you very accurate analytical process. Okay, so I have 2 points. The point one is so data mining has 3 sources for the big data. Okay, then we have to do the data analysis for precise situation. So then the third one, you can see that. So his mouth is open widely, tell this person. So you can get out of here now, because since your welcome rate is very low, so you are allowed the guard we can serve, right? So, but anyway, so this means that so the decision process has been reversed by the big data process. Normally, he only can report to his boss to make a decision, but now he can rely on the big data system to make a decision to reject these customers. Okay, so that's totally different from structure of the business point of view. So this is the definition of NSF, by USA, okay, National Science Foundation. The ideas provided by year 2012. We can see this is very, very genetic, definition. And you can see the last words is all other digital sources available from now to the future. Okay, this is very important, right? So that means everything, even right now, my speech, and whenever you use your cameras, use your cell phone, so you raise your voice, you take photos. That's all the way to generate big data. So it's very genetic. In China, what we did in year 2012, 2013, we hold several, conferences, and we got the following, definitions from our point of view. The first one, we see that, definition from Xiangshan Conference in Beijing, year 2013 in May. And we see that big data is collection of data with complexity, diversity, heterogeneity, and high potential values, which are difficult to process and analyze in a reasonable time. So this is very important. Why? Because all the algorithms we use now is based on the digital data. It's not non-traditional data, okay? Or we call the structured data. It's not the non-structured data. So which means that whenever we're giving hundreds of thousands of photos, hundreds of thousands of articles or text files. We cannot use effective method to analyze it. So that's a problem. Okay, and in order to make sure our policymaker can understand the data, we put some data mining, definitions for the simple situations for the ordinary people. So we say that big data is a new type of strategic resource in the digital era, and the key factors to drive the innovation, which is changing the way of human beings' current production and living. So this is a very, very important idea. You see that this definition has been 7 years old. Has a big impact on the policymakers wherever they mention the big data. So China did its big data strategies on its 13th, 5 years plan. So that is from year 2015 to year 2020 by end of this year. So in order to understand, what's going on with China situation, we published a paper year 2017 to talk about China plan. So the China strategies basically come from first things we try to connect the government data with social data, so together, and sharing the exchange platform. Then we prepare the laws and regulations, and you know that in the world, the Europe Union has very strong law to protect privacy, and the U.S. has very, very losing laws to do the same issue. China could be choose between European Union law and the U.S. law between. Okay, so to make sure there's room for us to develop a big data business. So of course, China is also talk about industry chain, talk about key technology research, and also software, hardware, products, and so on. So this is our paper. So we use a very highlight to talk about what's going on with China big data strategy. We call the 1, 3, 10, 19. What do you mean? 9 is 1 means that the top design. 3 means 3 service platform. So the first one is the inter-department sharing. So this has been done. China put 2 levels. One is for the central government level, and also for provincial government from up to down, then from left to right. So to put them together as national system of big data. So this year 2020, China use a cell phone. Chinese citizen use a cell phone, to report the tax return. Okay, so this I think it could be the only country in the world to do this. So even U.S. cannot use cell phone to report your tax, right? So, and also China is trying to do something like open platform to open the government data. So this of course so far is a little bit slower, but also the service for the people. So that's a 2 platform. Then they have 10 big projects, among with 19 different governmental branch. So this is ideas we have. For those of you, if you want to look at paper, you can look at paper published in the Annals of Data Science. Our paper title is called How China Deal with Big Data. Okay, so now let's see. I'm trying to share with you about the challenging questions of big data. So this is from my point of view. So the first one is how to transfer semi and unstructured data into structured data so that the low-end data mining and business analytics tools can be applied. As I told you, all the algorithms which we use now is based on the digital data or structured data. If we have an unstructured, how can we do it? Hundreds of thousands of photos, hundreds of thousands articles. What do we need to do? So I published those ideas, in the magazine is called The Bridge. So this is an official magazine or journals by U.S. National Academy of Engineering. So in year 2014. So for those of you, if you want to look at what's going on, you can read my paper over here. So I have a paper is called Big Data History, Current Status, and Challenges Going Forward. So this is the paper I discuss those things. So the first one is how can we use a structured the way to transfer unstructured data. So this is just like by ancient Chinese story, okay? So the story says that there is a butcher who used a dung knife to cut the cow into beef. And one day, so the king asked him to say, how come you can use a dung knife to do the beef? And he said, your majesty. So when I say the cow, I didn't say cow. I just said bone structure of a cow. I use my dung knife just cut the joint of the bones. Then the beef will be made. So this idea means that if we say any, for example, if we have a photo which is non-structured data, we cannot see everything of the photo, but we see some interesting items from photo. For example, we can see the photo is taken indoor or outdoor. And we also can see that photo is for the man or for the human. So we can put the man and the human as index 1, indoor and outdoor as index 2. That means we can extract the structure of the information into the tables. So that's the idea which we want to do, okay? So let's just give you some ideas to see that. So if we see crackers on the road, we are not going to look at a cracker here. So basically we build the database for different crackers. We just match the cracker with what we need to analyze. So this is just like you go to airport. So people look at your ID, look at your passport. So they are matching your photo with something in the system, okay, about your photo. So that's also the match. So you see, we look at this index, right? Then we can find out this idea. Same thing for this bird, right? So we are not going to recognize this bird directly like this. So we just go through this whole thing to cut the photos into different parts and try to bring the chart over here. You can see this table. This table represents this bird. Then we analyze the table to go back to the original situation. We can get these results. So this is our idea. Okay, that's the first one for the challenge equation. The second challenge equation means that how to find the structure, how to find systematic models of the complexity and uncertainty of big data. This is just like blinds with elephants, right? So each person has different way to view the elephants. But our question is, how can we do from their information from different parts of the elephant to recover the elephant itself? So this is called complexity problem. So the third one is called what kind of relationship exists between the data structure and decision structure. So in the data structure we know that we have the first one we have the first one is called the structured data. The second one is semi-structured data. The third one is unstructured data. Same thing for the decision making. For those of you, when you just get your job, you make a comprehensive report to your boss. That report itself is called structured report. But when your boss puts some footnote or some remarks on your report to give his supervisor, so this is called the semi-structured report. But when you go to CEO will say, okay, yes or no. So this is unstructured. This is called non-structured. So we are talking about the data structure and decision structure. What's going on with the relationship? So this is a very, very difficult problem. Okay, so you can see this is challenging for the data analysis. Let me say one more time. I reviewed the 3 challenges. Challenge 1 is called, we try to transfer all kinds of non-structured or semi-structured data into structured data, then use data analysis. The second one is we have to handle complexity of the data structure to try to find out a different angle of the data view to put them together as comprehensive information. The third one is we have to handle between the data structure and the decision structure. So those things will, give us different impact of the data analysis. So for those of you, if you want to look at our book, you can look at those things we publish here. So I just want to point out to you some important stuff. For example, year 2004, so I organized a conference, need people to come from computer science to talk about the management, okay, knowledge management. And from knowledge management talk about what is data mining. We have put two kinds of people. One is from business, one is from computer science. So we have interactions. So this is a very important book. And we also have optimization-based data mining theory and applications. So you can look at the website to see our books. And we have intelligent knowledge, a study beyond the data mining to see what's going on with the knowledge after data mining with the way the decision maker can use. And I have a very, best sellers book, which you can find from Amazon to talk about those ideas. So that's just the situation we have. So now, we are still, going to the cases here. So the first case, so year 2006 to 2009, so we built the largest, credit systems for China because the population of China has 1.3 billion people. Now it's close to 1.4 billion. Okay, so which means that we influence every Chinese whenever they go to commercial bank, try to get a business loan. The commercial bank has to go to a central bank to look at the credit scoring of each person. So this one has been done in US. The second has been done in China. Of course, I'm talking big size, right? There are some countries in Europe, like Germany, they have different format. Like in England, they have something similar to USA. In Australia, they have their platform has been built by US corporations. But again, so we built this situation for China. So this is the models we use. You can see that. So over here, the model over here. So we have two models is by optimization method. So you can see the Gini score is very high, 88.9. So two scores. And there is a standard way is called logistic regression and support vector machine, right? So and this model you can see, especially for case score, is more than 10 points of US situations. So that means our model is better than the FICO score, which is produced by USA. So this is a comparison of the three countries situation. The US average score is 678, and China has four models, and Australia is 573. 574. And you know that anything below the 620 means subprime. So that means this is very clear. By credit scoring, we can classify each person. So your credit, liability and so on. So and you can see this is much similar for three countries because most of people using money to buy house, to buy cars, right? So that's the situation. So which we find. So theoretical situation for the reality. This definition, for the distribution of the USA. So you can see 8%, 5%, 2% people are classified, total together 15% as a score below 620. And here is the situation of China. You can see that. So because this is a Poisson distribution, so the normal distribution towards to the right. So most people are good. So that's the very, very important tools used by a commercial bank in China. And case two. So and this beginning of this February, and you see that our world now is in the pandemic expression, right? So and actually, the first week of February, when China has a big break of the pandemic, so we use the information collected by China CDC to predict what's going on with human beings, transmission patterns, and as well as when the society can go to the normal. So that's the trade-off analysis. So we successfully did for 6 cities. One is called Beijing, and Tianjin, Wuhan, Hangzhou, Suzhou, and Shenzhen. So 6 cities. So and we have a detailed planning about those 6 planning. So wherever the city is going to the normal, when it will should go normal. For example, if they should recover their normal life in the middle of March, by that time, for the city of Shenzhen, you may have 200 cases, right? So that will affect the society. But if you have your society reopen by the end of March, maybe you only have 50 cases, right? So this is trade-off to see how the economy recovery or should be. So this become very, very important decision support for the government to make the final decision. And actually, we have provided this model to our friends in Spain and in Italy so that they can use our model as well. So this is exactly the big data applications. We try to look at each cases whenever they went to hospital for the COVID-19. So we will see when they have been exposed to the certain age of people and a certain situation, either in your family or in the public areas and so on. So those things give us information. So we put the social data into the medical data together. So that's a paper. I wish some of you can find this paper to read. So that paper has been published, as I told you, in the journal is called the Clinical Medicine. So that's a very famous journal. So in China, we also use the APP to look for medical doctor. So and there's a very good company. So it's called the Chuyu Doctor. So we use this system to support them. They have in their website, they have served 140 million people around China with 450 medical doctors. So to look at, so it was our system to whenever you see you put information in your cell phone to looking for doctor by your symptoms, then our system will take you to find the doctor which whoever you need. Okay, so this is very effective for time. I mean limitation. I cannot go to details. So that's how the big data of healthcare come from. So that's just to show you the platform of this, information. Then we have automatic, trending systems, which I'm talk about. So now I will go again to talk about something else. So for example, so we have innovation entrepreneurship index. So this is very, very important. This need one of my students who have startup companies. So it's called 36KR. So you can see that. So this is a very young student. So and he was also invited by Chinese Premier Li Keqiang to open the innovation week for Chinese young people. And he took his company 36KR, went to Wall Street, have IPO last November, and also he joined the Jack Ma's group to study how to enlarge the business. The Alibaba's Jack Ma, right? That's my photo with Jack Ma about a few years ago. So my student and also related with his business. So we create not only for the academic student, but also students who are doing the, entrepreneurship, especially startup. So for the finally, I will give you about 2 minutes to see what's going on. So then first we have a journals. It's called ITDM. So you can look at this journal. This journal has been there for a long time. And also we have a new journal. It's called Annals for Data Science. Then we have international conference. So we go in this conference everywhere, start with USA, go around the world. And last November, it was in Spain, but this year supposed to be into China because the pandemic has been postponed. I wish some of you, the audience, you can join our conference later on. So I just show you some, photos of conference without the details. Okay, and I also have an interest to do the Silo American Venture Capital Summit. So this summit is related with, the famous businessman Warren Buffett in USA. So we started with this summit in year 2016 and 2017 and then 2018 from this conference. So we bring all the Chinese businessmen to have a talk with US businessmen, try to look at, innovation and entrepreneurship. So that's related with big data as well. So this May, so we did this conference again. So this conference for this May. So because of pandemic, so we went to online. And you can see our conference where we broadcast this conference from internet. We have 160,000 people join our conference. And Warren Buffett also went to online. So that means online will change our life, right? Just like today's lecture I give to you through online conference. So finally, there are so many challenges. For example, so how we can measure AI. So we have very interesting research based on Turing test and von Neumann's architecture for the testing. And then, we have DIKW, pyramid. So those kind of ideas. What we are doing is we use IQ of human being to test the machine, to say how machine IQ looks like. This is our research paper. You can take a look from different journals. So, and actually we published 3 papers year 2017. So MIT Technology Review showed our paper to see it's very interesting, right? So according to our analytical process, so the smart, the best, search engine like Google, it's compared with human being, it's just like a 5.5 years old human in terms of IQ. So there are so many, website look at us how to use, IQ to test the AI, to test the machine, not only test the people, but test the machine, compare with the people. So this is the website talk about our situation. You can search on the website, how to measure AI by using IQ. So finally, I want to say that can computer be smarter than human? So 300 years ago, Leibniz, the German, mathematician, found battery systems, right? Because of that, now we have a computer to serve us. So what I want to say that now even computers are very powerful. Computer can do AlphaGo, play with Go, but a computer cannot play with human. For example, if we have 4 humans to play, we have 3 humans play mahjong. That's a lot of, bridges of Chinese one. So if I give the eye contact to another person, but the computer will be out of control, out of, calculation. So by that time, so my idea is very clear. Whenever the computer going back to multiple systems, multiple value systems, not only battery systems. By that way, computer has better way to calculate the complexity of the human thinking. So in that way, we could have a better, AI developed. So again, from a current point, we have a long way to go to have a smart AI, smart machine, just like our human being. So this is the end of my talk. So I would like to say thank you for all the people, the organizer of conference inviting me. Also thank you for each of you who listen to my lectures.